In this video, I'll show you how to import your custom manipulator models in IceXim. Additionally, I show you how to integrate that manipulator with the Isaac Python API, including joint controlling and executing pick and place, and finally interacting with real hardware. So let's get into it. The manipulator I'll be using in this video is the MirrorBot, an educational robot from Vilcata. It has a total of 6 axes and it priced about 1.8k USD. And since it provides CAD files and URDF files, I think it'll be easier to integrate that into IceXim. Next, I'll cover the following topics in this video. First, URDF importing. Import your robot to IceXim based on its URDF. And second, tuning the gains of your robots and its joints for more realistic robot movements. And third, implementing a surface grip roll in IceXim for grasping objects. And fourth, follow target and pick and place examples. IceXim already have some fancy and great examples that is made of Python. So learning the provided examples, I'm gonna show you how to implement that and integrate that into IceXim model. And finally, I implemented a simple digital twin via LOS 2 and also show you how to set up the physical robot. You'll need the URDF file for your robot. In the case of the MirrorBot, the well-configured URDF is already provided, so I'm gonna use that. Even if you don't have a URDF file, most of the CAD programs like SolidWorks or Fusion 360, they already offer URDF exporters, something like that. So give it a try with that. And before importing the URDF into IceXim, there's a crucial stop to point. That is, the latest version of IceXim. The latest version now is 2023.1.1. This one has a bug when importing fixed robots like manipulators. Therefore, I'll be using version 2022.2.1, this one, only for your div importer. So let's click this IceXim and launch that. Okay, so open the USD file you made before. You can drag and drop this USD file, or you can import that USD file from the navigate panel over here from the content tab. So let's make it more bigger and open the gain tuner to Isaac utils and workflows. Here it is, gain tuner, and press the play button. And from the selection panel and select articulation, click your robot. Yeah, you might can see those some kind of many parameters like this. I'm gonna show you briefly talk about those parameters later. But now, just click the start button and click on this randomize button several times and check that your manipulator works well and successfully arrive to the target points. Great. As I mentioned earlier in this tutorial, I will not tune those gains precisely. Instead, if the robot is functioning well like this, you can just keep going. However, if your new robot moves too slowly or too radically, you might have to adjust those parameters. And here's two kinds of parameters. First thing is stiffness and second one is damping. Stiffness is some kind of spring, something like that. So the spring, if the spring is too stiff, it will move more radically. And the second one, damping, is something that distorting your joints movements. Therefore, if the damping becomes so much larger, then even if I click this randomize button, the force joints over here will not and cannot arrive to the target points because some kind of huge disrupting something is blocking this joint. So let me change those parameters more small. Yeah, as you see in here, since damping becomes more smaller, it starts to move. Therefore, you might have to adjust those two stiffness and damping parameters properly and save your USD file again. And save the file like this. If you successfully saved your new USD file, and in here, and now as I said before, now you have to exit this iSIM 2022 version and turn on this iSIM brand new version 2023 version. Let's keep it up. Start button. At this point, to prepare for upcoming examples, I would recommend to clone two GitHub repositories I have prepared. Firstly, this one, clone this mutable loss 2 repository. And in my case, I did it in here. And don't forget to recover your previous this URDF folder. In my case, its name was URDF_preb. Therefore, I will delete this folder and recover this name back into just URDF_2. And next thing you have to do is launch the Nucleus Navigator over here and click the launch button. Yep. And then unload the entire this repository. Yeah, unload this entire repository in your Nucleus server, like this. And to be honest, since I have multiple projects going on, I made this project folder and this RB lost folder, and I uploaded my repository over here. So you can change your folder, whatever it is. However, you have to keep in mind where you located this mutable loss 2 button, and you might have to change the path from the codes. And next, clone the repository containing the iSIM demo codes. This one is named RB_mutable example. So I cloned that over here. And this code is a kind of special repository and is made through the OMNIVERSE extension template, making it convenient for use in the iSIM. Therefore, if you click this window button and extensions button and move to this hamburger button, click on this and click on this setting button like this, and I'm gonna trash that. Yeah, let's assume that you're the first. This is the first setup of your setting. And plus this, click on this plus button. Next, get the location of your clone repository that is named / something blah blah, and copy and paste over here and click the enter button. And you might see and watch this kind of fancy logo and icon extensions over here. And if you click this toggle button, you can see something over here. Click this iSIM examples, and you can watch there's a new tab that is named RB mutable example and several example tabs. About the auto load button, this is, yeah, if you enable this auto load, you don't have to click this and clicking this toggle button whenever you launch this iSIM 2023. So I'm gonna just enable this auto load button. Next, you will need to make some modification to the file paths within the codes. Please, yeah, the name to two variable name is self_description path and self_URDF path. First one is the location of this repository and this example's location. The second one is the location of your URDF file local path. In my case, my URDF file is located in mutable loss 2 and description URDF, and yeah, in here. And in my case, my examples are located in here, RB mutable example, and in here, and here, and there's several examples. Change those variables. into your own local paths. I'm sorry to bother you, but I try to find many how to do that more conveniently. However, this one is the best one in now. Bear with me, please. Okay, now all the robot arms are ready to move in Isaac Sim. However, to grasp and manipulate the objects, we need to set up an end effector, something like surface gripper, parallel gripper, something like that. And in order to attach a surface gripper to our B robot, there's two crucial points to point out. And first one is, according to the Isaac Sim documentation, the surface gripper operates exclusively along the x-axis. Therefore, the local coordinate system, the local coordinate system of the end vector must be also oriented within the x-axis, pointing downwards. If you see in here, it looks like the x-axis is looking the forward of the mirror board. However, if I press on the W button, it changes into local frame like this. Yeah, click. It toggles between the local and world frame. Therefore, the local coordinate means now x-axis is looking to the downwards. You have to set up your URD file in this way. In the URD file of BRobot, such an considerations were not present. Thus, I created a new link called EE link and effector link and recreated the USD file within the URD importer. And the thing you have to keep in mind is that in order to use the URD importer, you should not launch this Isaac Sim 2023, but you have to launch the Isaac Sim 2022. So launch the 2022 and import again and save the US file and exit and launch this 2023 version again and import again. Oh, kind of tough, but yeah, now it has some bug in 2023 version. So yeah, keep that in mind. For understanding how the surface gripper works, I made a simple example program. So click on the Isaac examples, navigate through the mirrorbot example, and click on this button, surface gripper, and click on this load button. Yeah. If you do so, you can watch surface gripper of the mirrorbot, and a small box is appeared. Let's click this button and let's change the state of our gripper into closed state by clicking this open button, and let's apply some little bit of force through clicking this apply button. Oh, I made a mistake again. Let's do that again and click this close button and apply. Yep. As you see in here, you can watch that this gripper is holding the objects. Therefore, if I apply some force onto the gripper, the objects will move together with our gripper. And it allows you to test whether the gripper has correctly grasped the object and to what extent force is needed to move your object. Let's move to the code. Okay, from surface gripper and surface gripper.python, Python code and line 300. Yeah, you can check that there's some various kind of parameters for your surface gripper, including force limit and torque limit, something like that. So tune the code according to your gripper model, and also try to change the geometric and physical parameter of your objects into your own objects. So you can test the code and test your gripper before implementing the whole simulator. Let's move to the next example. Navigate to the Isaac examples and BRobot example and click on this follow target button and click on this load button. Okay. And finally, click this play button. And as you see in here, our mirrorbot will try to do his best to follow this green cube over here. So therefore this example name is follow target. And how can I implement this is the core API of Isaac and Isaac Sim provides an example code that is called follow target. And I integrated it with Miroba so that it can simply follow a queue. The detailed explanation of this example code can be found from the official Isaac Sim tutorial in here. Therefore, I'm gonna just skip that here. Instead, I'd like to highlight the parts you would need to modify if you were integrating it with your new manipulator. At the top of our follow target example, the Python code, you'll notice some additional files named rmp flow command.yaml and robot descriptor.yaml file. Yeah. And those YAML files are used in this controller / rmpflow.py the Python codes. Yeah. What are those YAML files? Let me briefly explain this before moving on. First one about RMP flow. RMP flow is the name of the algorithm that calculates the motion of the robot arms to ensure smooth movements and collision avoidance with itself and obstacles, and so kind of maintaining a safe distance while moving. The configuration files are required, and these files in Isaac Sim are rmp flow underbar command.yaml file, this one. And the second one is robot descriptor.yaml file. Those two files are required. Tuning these files requires an understanding of algorithms like Lula RRT algorithm and RMP flow itself, which might not be straightforward. Therefore, I just focus on explaining the minimal modification needed. First, from here, robot descriptor file, ensure that the joint names and their counts match with your robust configuration from URD file. As you see in here, the URDF joint names are joint 1, joint 2, not the joint underbar 2 or uppercase joint 2, something like this. So make sure that those names and counts are matched from your URDF and YAML file. Second, from the RMP flow command file, make sure to specify the appropriate robot base and end vector link in these sections. If you would like to know more about this RMP flow and YAML files, please refer this official documentation from NVIDIA, Isaac Sim. Next one is pick and place. Navigate to the Isaac examples and click on this pick and place button. Load our manipulator and small cubes over here and click this play button. It'll do a pick and place, and the task of grasping an object and moving it to a desired location like here is commonly referred as pick and place. Typically, achieving these tasks involves complex mathematical algorithms for robot control, trajectory generation, and motion planning. However, in Isaac Sim's manipulation controllers, they already implemented all those kind of algorithms and controllers over here. And you can find some core APIs of this pick and place controller from Isaac Sim documents. Let's dive into the code from pick place example, the Python code. Now it's importing pick and place controller from controllers.pickplace, the Python code. And here in pick place Python code, now this class is inheriting from pick place controller that I showed before from OMNIVERSE Isaac API, Python API. And surprisingly, this pick place controller requires RMP flow controller again. And again, RMP flow controller requires two main YAML files, configuration files that is named RMP flow command file and descriptor file. So now I think you understand about our hierarchy of example codes. Since our pick and place controller already know about the parameters for stable and smooth movements, therefore our pick and place can ensure about that safety. Looking at the main code, in here setup post load, you will notice the creation of this pick and place controller with variable parameters. And next move to this one, simstack copy function. This function is function they called whenever our simulations steps are counted. So in here, we can see that our controller will calculate about the robot actions based on this pick place and place, and finally the parameters for safety controls. Lastly, before moving on to next example, let's uncomment the two sections labeled in case in our code. Yeah, toggle those two code blocks, and let's move above and here too. Let's toggle those two parts. Save that. Don't forget to save that. And navigate to our example and click on this pick and place example again. And don't forget to click this load button. Now the objects is not a basic cube, but some kind of fancy bin. By doing so, as you see in here, you can test pick and place for a new object instead of previous cube. And if I move this again, yep. Yes, in here, obviously pick and place can become unstable depending on the mass and inertia of the objects. This one is more heavier and its inertia is much more, now it has more bigger volume than previous cube. Although this looks sucks and not good, but this is the reason why Isaac Sim is the best simulator. It can represent such kind of physical properties. I just wanted to show you about this. Finally, the last example, here's an example of synchronizing real robot with Isaac Sim. Let me get to the pick and place loss 2 and click this loss button. When you run the example, it may seem similar to the previous pick and place example. However, if you open the terminal and type in the loss2 topic list, you can watch there's some kind of lost2 topics. And let me echo this Isaac joint comments. Now it's simultaneously giving the data of our joins from the Isaac Sim to our new terminals. And this indicates that the communication is taking place between the lost2 environments and Isaac Sim. Which one? That allows for synchronized movements of real robots and simulations. And honestly, the gist of this system is lost2 bridge from Isaac Sim and Isaac Sim's OMNIVERSE. You can watch this from Create, Visual Scripting and Action Graph. By clicking this Modifying button, you can check how this OMNIVERSE is configured. Now we cover detailed explanation of this in another video. Anyway, by transmitting joint state topic published in Isaac Sim to the real robot and making the real robot act accordingly, you can implement a simple digital twin application. For the setup and lost codes for MiniRobot, please refer to my Github Repository. So don't forget to subscribe my channel and clicking the like button. Everybody have a great night and have a great day.